Today we're going to tackle experimental design. This is not a one and done topic. We are going to have to work on this all year long. So today I just wanted to start with like basic dependent, independent variable controls and things that we'll be experiencing all the time. This particular topic is a must master. If you do not master this topic, you will struggle the whole year and probably will even struggle to do well on your AP test. And so please, I can't stress it enough. Pay attention, practice these skills, and make sure that you're ready so that you can utilize them in any sort of environment that we have. Okay, so in your reading and also in pre-AP biology, you should know that there's a dependent variable, there's an independent variable, there's a control group, there's constants, or sometimes they're called controlled variables. I like to call them constants because control and control variables just get a little confusing. And that you need to keep these all separate. Dependent variable, that's your data. Independent variable, this is what you're manipulating. Control group, this is your comparison. Constants, these have to remain the same throughout the entire experiment. Okay? So, and what we're gonna really work on today is a couple of different types of control. But first of all, let's just get these little factors done. Okay, I hope you can see a straw. That's a straw right there. And it is going to house, not in this thing, but in class, hopefully, it's gonna house some fruit flies. Flightless fruit flies, so that we don't end up with gnats all over the building. And on either end of the straw, we are going to put a cotton swab, aka Q-tip, toothpick, I'm so silly, in the ends to keep the fruit flies in. There's one and two. All right, so those are nice, tight, and snug fit. And on those cotton swabs, we are going to have something to entice the fruit flies. So the research question is, what do fruit flies prefer? That says flies, in case you can't read my tragic handwriting. And you'll have a specific research question, like, do fruit flies prefer blank over blank? And then you'll come up with a hypothesis, and your hypothesis might be fruit flies prefer you see that? No? Come on. Vanilla syrup over Karo syrup. Okay, so this is actually not a hypothesis. What? This is a prediction. Fruit flies prefer vanilla syrup. Okay, if you want to make a hypothesis out of this, then you need to go on to the because. If fruit flies are given, okay, maybe you remember if-then statements, right? If fruit flies are given vanilla syrup, they will move towards it. They will prefer it because vanilla has blah, blah, blah in it that stimulates the fruit flies' neural response, and they are attracted to that, whatever. That's where your research comes in, okay? You need to have a reason that you chose your hypothesis. You might go with sugar content. You might go with the actual like olfactory system in the fly, the nose system in the fly. You might go with, I don't know what. You have to research it and come up with a thing. So you would say fruit flies prefer vanilla syrup because, so if you were to say because, then you would say vanilla has the property of blah, 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 which is attractive to fruit flies' olfactory senses. Cool. All right, so and that's just, and this one really is kind of a terrible one for hypothesis teaching, but you can come up with a good hypothesis. All right, so then we have to decide, what do fruit flies prefer? Or we actually have to decide if our data are going to support our hypothesis that the vanilla syrup is attractive to the fruit flies. All right, so what we're going to do is we are going to set up a series of experimentations. So what if I just had just this, an empty straw? And over here, I had the vanilla. And over here, I had the sugar water. First of all, what is the purpose of this right here? What role does the vanilla have in this experiment? It's the independent variable, okay? What role does the sugar water have in this experiment? Giving you time to answer. It's the control group. Why? Because what if we just put vanilla on both sides of the straw? What if the flies went to the vanilla? How would we know if it was the vanilla that they preferred or the fact that it's a vanilla syrup, so it has sugar in it? How could we tell the difference? Really, the only thing we can do is we can isolate the vanilla. And so this is vanilla syrup. I probably should have wrote that. Is isolate the one that has vanilla on it and that in it. And that way we know that if the flies go to that side, it's not just the sugar they're attracted to, because this one should be the same concentration of sugar and water, but it would be actually the vanilla. We can't tell if they are, quote unquote, preferring the vanilla side unless we have a control group to compare that to. I always tell my students, if you don't have a control group, you don't have an experiment. You just have a fun activity. We aren't doing fun activities in this experiment. We'll do some, but we are doing an experiment, okay? All right, so what is going to be my dependent variable then? What would I use for my dependent variable? What is the data that I am collecting? How many flies are on each side? So my dependent variable would be the number of flies. All right, so let's say I set up my experiment and I had one Q-tip with sugar water, one Q-tip with the vanilla sugar, and then I put some fruit flies in the middle and I counted how many went which direction. That's the whole point, right? Okay, well then what if Miss Wilhoit said, I mean, you probably better put an empty straw there with Q-tips in it. Why? Why would you want an empty straw with Q-tips in it? Because of something called a negative control. Now, I'm going to tell you that I really don't think you need to put an empty straw with Q-tips in it. But I'm going to use this to really try to hit home the concept of a negative control. There will be experiments that you need a negative control. What is a negative control? Well, a negative control, you expect nothing. No results. If I don't have fruit flies, I should get no fruit flies on either side. What if I got a fruit fly? Then something's wrong with my experiment. There's something wrong. The Q-tips aren't tight enough, and so flies are getting in. Maybe there was some fly larvae in the straw, and it happened to hatch while my experiment was going on. I don't know. But what I do know is that if I put no fruit flies in this straw, there should still be no fruit flies in the straw at the end of the experiment. And if there is, then something is wrong. So a negative control is used to test the validity of your experiment. If you're testing enzyme activity and you're testing to see how many bubbles are produced when you put something in with an enzyme, and in one test tube you put the something in but no enzyme and you still get bubbles, then you know that you have something causing bubbles that isn't supposed to, and it's going to mess up your whole experiment because you're sitting here attributing all these bubbles to enzymes when there's something else that's making bubbles, and you now have to investigate to figure out what's wrong with your experiment. You have an experimental flaw. And it's going to cause you to have data that aren't accurate, that aren't valid. And any other person that peer reviewed your research would come back and say, your experiment is messed up. And so that's why you need a negative control. Because if something is going on here that your whole thing, like your whole experiment is setting on, like your research subjects, your fruit flies, like the whole experiment is counting fruit flies. And so if you have put no fruit flies in there and some show up, your numbers are going to be off. I don't know where they come from. Okay. So a positive control then, okay, there's really not a very good positive control for this experiment, except I think we can come up with one. All right. So a positive control is one where you know you're going to get results. Okay. So in this instance, maybe we would put their typical sugar water on both sides. Let's take off independent variable. Let's take off control group. Right now, we're just running a control. And it's not going to be an empty straw anymore. Okay, so we are going to do sugar water over here as well. And we're going to put little fruit flies inside the straw. See, I'm going to see if you can see them. They might look like fruit flies. I don't know if they will or not. They look like fruit flies in there? Oh, that's so cute. Okay, so there's the fruit flies buzzing around inside the straw. And look, they're going towards the sugar water. Let me give you a time when this would have been helpful. Last year, we put the fruit flies in the straw and they went into some sort of, it's really, really cold in this classroom coma. And so we didn't get very good results. If we hadn't realized that they'd gone into a coma, we might have attributed their lack of movement to really enjoying one side of the Q-tip or not of the other. So what we needed to have is a positive control, one where you know there will be results. Okay, and if something happens and the fruit flies just sit in the middle and don't go anywhere, then something's wrong with your experiment, right? Something's wrong with the actual experiment. And so it's not that they like one. So you need to have a positive control to be sure that your experimental, your equipment and your experimental design is actually working. Otherwise, you could run your whole entire experiment and attribute the fly's movement to their lack of or their attraction to one of your substances and not knowing the whole entire time the problem is the fruit flies aren't going to move at all because they just are too cold or they don't like their environment. And so you should run a positive control where you are actually testing to make sure the equipment works. So a positive control, you're actually saying we are going to get results. A negative control, you're saying we should get no results. And if you don't get what you expect with your positive control and your negative control, then you know that your experimental setup is incorrect, not working. Okay, remember, those are completely different than the control group. All right, so the control group is the one where you have a comparison. So in this experiment, your vanilla is your independent variable. And then your regular old corn syrup, probably actually better to just use sugar water, but your regular old corn syrup would be your control. And this is your independent variable. Okay? I need you to study those. I need you to really, really, really wrap your mind around and understand it. And I'm going to ask you some questions about them, and I want you to be a master of experimental variables in a controlled experiment. All right? I think we're going to get this one too. Have a great day.